How cool is this? Super Impulse's tiny arcade line. If you've seen it already, it's a series of 4-inch tall, fully playable arcade cabinets, and it's a pretty fun way for 80s kids to relive their childhood spent stuffing quarters into arcade machines. But for those times when you're away from your desk and get the itch for some Pac-Man or Missile Command, Super Impulse has now created a new micro arcade line that now puts those classics on machines no bigger than a credit card. They're not quite as thin as the Visa or MasterCard that you've just whipped out of your wallet while desperately searching for a pre-order link, but the micro arcades still managed to squeeze a full-color LCD screen, sound effects, physical controls, and a micro USB charging port into a wallet-friendly handheld that's just over 3 inches long. Yes, your smartphone can already play countless classic game titles, but as we've talked about before, an emulator's touchscreen controls are really a poor substitute for real buttons. Super Impulse has also made some improvements to the original design, including the color screen upgrade and the ability to play games that require a little more horsepower under the hood. Micro Arcade Series 1 will feature 3 different versions at launch. You get Pac-Man, Tetris, and an Atari combo card that includes Missile Command, Centipede, and a third unknown game that they're going to reveal at the New York Toy Fair. When available later this year, they're going to sell for between $30 and $35, which is going to make them hard to pass up if they're stacked near the checkout aisle. 3D printing has changed the way people approach hardware design, but most printers share a basic limitation. They essentially build objects layer by layer, generally from the bottom up. This new system from UC Berkeley, however, builds them all at once, more or less, by projecting a video through a jar of light-sensitive resin. The device, which its creators call the replicator, is mechanically quite simple. It's hard to explain it better than Berkeley's Hayden Taylor, who led the research. He said, basically, we've got an off-the-shelf video projector, which I literally brought from home, and then you plug it into a laptop and use it to project a series of computed images, while a motor turns a cylinder that has a 3D printed resin inside it. Using light to print isn't new. Many devices out there use lasers or other forms of emitted light to cause materials to harden in desired patterns, but they still do things one thin layer at a time. Researchers did demonstrate a holographic printing method a bit like this using intersecting beams of light, but it's much more complex. In Taylor's device, the object to be recreated is simply scanned in such a way that it can be divided into slices. It's a bit like a CT scanner, which is actually the technology that sparked the team's imagination in the first place. By projecting light into the resin as it revolves, the material for the entire object is resolved more or less at once, or at least over a series of brief revolutions, rather than hundreds or thousands of individual drawing movements. This has a number of benefits besides speed. Objects come out smooth, if a bit crude in this prototype stage, and they have features and cavities that other 3D printers simply struggle to create. The resin can even cure around an existing object. Naturally, different materials and colors can be swapped in, and the uncured resin is totally reusable. It'll be some time before it can be used at scale or at the level of precision traditional printers now achieve, but the advantages are compelling enough that it will almost certainly be pursued in parallel with the other technologies available. The paper describing the new technique was published in the journal Science. A Chinese research team has developed the ability to mind control a rodent, building a wireless brain-to-brain system that enables a human to move the rat cyborg through a maze. The research published in Nature Scientific Reports on February 4th detailed a brain-to-brain interface that connects a human brain to a computer, which then decodes and stimulates the rat brain to move. The researchers detail their methodology in a delightful section of the published paper called Rat Cyborg Preparation. operation, explaining how they implanted electrodes in 2 sections of the rat brain. The researchers then trained the rats by using the electrodes to produce certain movements, which they wirelessly sent to the rat's brain via a tiny rat backpack containing the stimulator. Their first test for the rat cyborg involved a maze shaped like an 8-armed asterisk. The rat started in one arm of the maze and was tasked with moving into another arm. The human controller was fitted with the device known as an EEG to measure brain signals. The EEG was connected directly to a computer. The computer would then decode human brain signals and pass it through a model to stimulate the rat's brain and tell it to move in a particular direction. Using the EEG to measure the human brain signal means the researchers don't have to directly connect electrodes to a human brain. That's a good thing, but it makes the signal a little bit weaker. EEG measures electrical activity in the brain through the skull. EEG gives us a fast signal, but because the skull and skin are not very conductive and are quite thick, it doesn't give a good spatial signal from the brain itself. That comes from a biomedical engineer at the University of Auckland and not associated with the study. He compared the signal from the EEG to reading a book through several layers of frosted glass. Using such a method prevents information from quickly being passed from human brain to rat brain, which means there's a type of input lag that humans need to account for when guiding the rat through the maze. The brain signals for left and right can be decoded, but to move the rat forward, the researchers used an eye blink. However, on average, the rat cyborg still moved through the maze in around 3 minutes. The rat cyborg was also subjected to a slightly more complex maze with a predetermined route. On average, moving the 6 rats through a predetermined route through the maze was successful 90% of the time. Over 10 consecutive tests were given. Researchers have worked on brain-to-brain interfaces before with varying degrees of success. In 2013, in fact, a BBI linked a human brain with the rat, enabling the human to influence the movement of the rat's tail. In 2016, a human brain was linked up to a cyborg cockroach and enabled the human to move the cockroach through a S-shaped track with limited success. This is the first time, however, that a brain-to-brain interface has been used to complete a complex navigation task. In a previous paper, the team suggested that rat cyborgs may have great potential in search and rescue operations. The rats would be able to slip in and out of dangerous zones, potentially controlled by a human from a safe distance. Could they use this technology to navigate a rat carrying a small walkie-talkie and camera through a collapsed building looking for survivors? Well, it looks like that, yes, they actually could. But a hand-operated remote control would probably be a lot more reliable. For now anyway, the technology remains in its infancy, but it does begin to raise ethical questions about the use of mind control on other species. In the study published on Monday, the team notes that all experimental protocols were approved by the ethics committee at the university.